Good afternoon, my dear children. Welcome to mathematics class. Chapter 4 Pairs of linear equations in two variables. In previous class, you learned how to write just the general form of a pair of linear equations in two variables and general form of linear equation in one variable, and then how to recognize or how to identify the given pair of lines are parallel, intersecting, and coincident or dependent lines, consistent or inconsistent lines by through the graph. In today's class, you are going to learn how to find the values of x and y, or how to find the solution set of the given pair of lines by solving both the linear equations in substitution method as well as in elimination method, that is solving the pair of linear equations algebraically. Let us move on into the content. Solving the pair of linear equations in two variables algebraically. The first method is elimination method, and the second method it is called as substitution method. Elimination method. In this, first we eliminate one of the two variables by equating its coefficients. Actually, what we do when the two linear equations are given, you must eliminate any one of the variable by equating their coefficients. So let us see how that is to be done. Solve 3x plus 2y is equal to 12, 2x plus 3y is equal to 4. So here I just wanted to eliminate x. You can eliminate even y also. So here I wanted to eliminate x. So I must equate the coefficients of these x for both the linear equations. Here 3 is there and here 2 is there. So if you multiply this with 2, and this will become 6, and if you multiply this 2 with 3, then it will become 6. So multiply this complete equation with 2 and multiply this complete equation with 3. So 2 into 3x, which is 6x, 2 into 2y, which is 4y, and 2 into 11, that is 22. Similarly, 3 into 2x, which is 6x, 3 into 3y, which is 9y, and 3 into 4, 12. Now write both the linear equations. And here, now we got the x variable, the variable x coefficients we made same. But the signs are not, the signs are same. The signs are same, both cannot be eliminated. So to make the different signs, if you subtract these two equations, then you must change the signs of the second expression. Then this plus 6x is going to change minus. Here plus 6x, here minus 6x, both will be getting cancelled. Now here plus 9y changes to minus 9y. So 4 minus 9 is minus 5 is equal to 12, 22 minus 12, because here plus 12 is there, but plus 12 changes to minus, so 22 minus 12 is 10. 5y minus 5y is equal to 10, then y is equal to 10 by minus 5, that is equal to minus 2. We got now y value. Substitute this y value in any of the equation, either the first equation or the second equation. But I substituted this in the first equation. This 2x plus 3y is equal to 4. Then 2x plus 3 into y value is minus 2, so write minus 2 is equal to 4. Then 2x, 3 2s are 6, minus 6 is equal to 4. Now this minus 6 you transfer the other side. 2x is equal to 4 plus 6, that is equal to 10. And then x is equal to 10 by 2, that is 5. So solution set, that means the values of x and y are x is equal to 5 and y is equal to minus 2. Now the substitution method. This method is useful for solving the pair of linear equations in two variables where one variable can easily written in terms of the other variable. That means here what we are doing is that one variable we are writing in terms of the other variable. Let us see how it is. Example, 2x minus y is equal to 5, 3x plus 2y is equal to 11. You can take any of the linear equation here into variables, any one equation. I have taken the 2x minus y is equal to 5. Now I will convert this in terms of one variable, this complete equation. That is 2x is equal to minus y, you transpose this side, 2x is equal to 5 plus y, then x is equal to 5 plus y by 2. So this x value I have to substitute in the second equation, not in the first. If you substitute in the first equation, you get again the question, the same equation you will get it. So you have to substitute this x value in the second equation. We have taken first equation and we have converted the variable x completely. So that is to be substituted in the second one. So if you want to take, you can take even this equation also. Then first find x from this. That means convert it in terms of x. That x value you can substitute in this equation. Anyway, you can do it. So this x value now I have to substitute in the second equation, that is x plus 2y is equal to 11. So 3 into x value is 5 plus y by 2 plus 2y is equal to 11. So 3 into 5, 15, and 3 into y, 3y by 2 plus 2y I can write as 2y by 1 is equal to 11. So what is the LCM of 2 and 1? 2. Cross multiply. 15 plus 3y into 1 is 15 plus 3y, and 2 into 2y, which is 4y. So here this is children print mistake. This is not 1, this is 15. Okay, once again I'm telling you, this is 15. So 15 plus 3y plus 2 into 2y is 4y is equal to 11. Now cross multiply. The whole thing multiplied by 1 is the same, that is 15 plus 3y plus 4y is equal to 11 into 2, 22. Now 15 plus 7y, 3y plus 4y is 7y. 15 plus 7y is equal to 22. Then 7y is equal to 22 minus 15. Transpose 15 the other side. Then 7y is equal to 22 minus 15. Then that is equal to 7. So 7y is equal to 7. Then y is equal to 7 by 7. It is equal to 1. So now we got y value here. Now this y value you can substitute now in any of the equation. This here the constant value is small, so that's why I have used the first equation. Substituting y is equal to 1 in 2x minus y is equal to 5. Then 2x minus 1 is equal to 5 because y value is 1. In place of y, I have written 1. Then minus 1 transfer to the side. 2x is equal to 5 plus 1, that is equal to 6. Then x is equal to 6 by 2, that is 3. Therefore, solution set is x 3 and y 1. So first what you have to do, any equation of the two equations, any one you could take it and convert it completely in terms of x or y. Then substitute that x or y value in the second equation so that you'll be getting the value, complete value. That means a constant, the value of the numerical value of x and y, you will get it from that. Then after getting x or y numerical value, that you have to substitute in the any of the equation to get the other variable value, constant value. Okay. Now some questions from exercise 4.1, how to solve it. Because first you must know how to frame the equation from the for the word problem, and then how to solve it also, because one sum I did in elimination method and other sum I did in a substitution method. That is the first one. Neha went to a sale to purchase of some pants and skirts. When her friend asked her how many of each of she had bought, she answered, the number of skirts are two less than twice the number of pants purchased. Also, the number of skirts is four less than three times the number of pants purchased. Find the number of pants and skirts purchased. So here the two things are the skirts and pants. We will assume that number of skirts as x purchased as x, number of pants purchased as y. First condition you see, number of skirts are means x, r means equal to, x is equal to 2 less than, you know that minus, twice the number of pants purchased. That means here we have to assume that pants I have taken as a y. So here that means we have to take here that x is equal to number of pants. That means 2y minus here what we get it here, less than 2 less than minus 2. That means x is equal to 2y minus 2 is the first equation. The second one is number of skirts is, that means x is equal to 4 less than 3 times the number of pants. Number of pants we assumed as y. So 3 times means 3y. 4 less than means minus 4. So x is equal to 3y minus 4. So let us see what is the solution here. So let the number of skirts is x, number of pants purchased as y. So first equation is x is equal to 2y. 2 times the pants purchased purchased, 2 less than 2 times the pants purchased. That means 2 times means 2y, 2 less than means minus 2. So skirts is equal to. Similarly, the skirts is equal to 3 times the pants, 4 less than 3 times the pants purchased. Means 3y minus 4. Now I did both these two, solving these two equations in elimination method. So x minus 2y is equal to minus 2 because I transposed minus 2y to the left hand side of equal to. So x minus 2y is equal to is already there on the right hand side of equal to, so it won't change, it is minus 2. Similarly, second equation, x minus 3y is equal to minus 4. I transpose 3y to the left hand side of equal to. So x minus 3y is equal to minus 4. Now again here both x variables with their coefficients are same, because here x no coefficient means we have to take it as 1. Here also x no coefficient means we have to take it as 1. Both coefficients are same but signs are same. So we have to subtract both the equations. So when you subtract the equations, this plus x will change to minus, then minus 3y change to plus, and minus 4 changes to plus. So both my plus x and minus x are cancelled, and minus 2y plus 3y. That means the result is y. So y is equal to minus 2 plus 4. That means you have to subtract 4 minus 2, 2, and here 4 has positive side. So answer is 2. So y is equal to 2. Substitute this y is equal to value in any of the equation. I have to substitute it. I have substituted in the first equation. That is, substituting y is equal to minus 2 in x minus 2y is equal to here minus 2. This is minus 2. Then x minus 2 into 2 is equal to here minus 2, children. I'm sorry, you have printed mistake, minus 2. Then 2 2s are what? 4. X minus 4 is equal to minus 2. Then x is equal to transpose minus 4 to the right hand side of equal to minus 2 plus 4. Minus 2 plus 4 is what? 2. So number of skirts purchased is 2. Number of pants purchased is also 2. Now the second question. 10 students of class 10 took part in a mathematics quiz. If the number of girls is 4 more than the number of boys, then find the number of boys, and here I'm sorry, it's not boys, that is girls. So we assume here that the number of girls as x and the number of boys as y. Total students are given as 10. So according to the question, total students means what? Number of girls plus number of boys is 10. Means what is the linear equation? X plus y is equal to 10 is the first equation. The second equation is number of girls is, it means x is equal to 4 more than the number of boys. That means x is equal to y plus 4. That is second equation. You see here x plus y is equal to 10 and x is equal to y plus 4 is the second equation. Then transpose y to the left hand side of equal to, then you will get it here x minus y is equal to 4. That is the second equation. Now this sum I solved in substitution method. So x plus y is equal to 10. From this I have converted in terms of y. So transpose x the other side. So y is equal to 10 minus x. I have to substitute this y is equal to 10 minus x in the second equation, that is x minus y is equal to 4. Then x minus y is 10 minus x. So write brackets 10 minus x is equal to 4. Multiply both the terms with minus x minus 10 minus into minus plus x is equal to 4. Here no sign for x means what? Plus. So plus x plus x. So means 1 plus 1 2. So 2x minus 10 is equal to 4. Then 2x is equal to 4 plus 10 14. Then x is equal to 14 by 2, that is 7. We have to substitute this x value in any of the equations. So I have substituted in this first equation. So substituting x is equal to 7 in x plus y is equal to 10. Then 7 plus y is equal to 10. Then y is equal to transpose 7 the right hand side is equal to, so 10 minus 7, that is equal to 3. So number of girls is 7, number of boys is equal to 3. So children, in this actually you don't have the sums from the word problems. You don't have how to find the values of x and y statement problems, but they may ask you to frame the linear equations from the statement problems. So you must know it. Sometimes they ask you to find it the values of x and y You can use it in any method that as what I explained in today's class, elimination method and substitution method. Any method you can do it, whichever method you feel easy, you can do the solution of x and y in that method. If particularly method is mentioned in the question paper, then you must do only in that method. If method is not mentioned, you can do in any method whichever you feel easy, you can do in that method. So, my dear children, I hope you might have understood the today's content very well. So, practice all these sums once again, and I'll give you some other sums so that you'll have some more practice on the substitution method, elimination method, and two non-statement problems and two statement problems. I'll give it so that you can practice. You will get practice on substitution and elimination methods. Thank you very much. Thank you, one and all.